Welcome to session 13 of Data Network Security 1. We'll be looking at integrating security in the software development life cycle, Sdlc. At the end of this session, we will look at how web application vulnerability testing can be implemented in our software development life cycle, and also we will understand how to use Microsoft threat modeling techniques such as STRED and DREAD to help you identify and prioritize web application vulnerabilities. Now, software-defined lifecycle basically defines the process for developing softwares, and there are many SDLCs or variations of them. Typically they have the same content or common elements. Now, why do we need to integrate security into our software development lifecycle? Now, discovering and resolving vulnerabilities earlier in the lifecycle will help us ensure web application security. Now, identifying and fixing these security issues in the early stages will help web application to have much less difficulty, and in terms of cost becomes less expensive. Now, testing early reduces cost and time to market, and we have the statistics in the design errors, coding errors, integration errors are all having some cost implications. Now, typical SDL stages, we have the business modeling and requirements, we have analysis and design, implementation, verification and testing, then deployment and maintenance. And each stage typically includes some type of validation mechanism. Now, business modeling and requirements. There are some requirements that one needs to look at. Customers are usually brought in to determine use cases. We have risk analysis, certainty of product successful completion, damage potential is evaluated, risks of new technologies involved. Now, so that has to do with the business or the requirement stage. Then we look at the analysis and the design stage. You can go through each of these modules. We have the implementation, we have the verification and testing, here typically performed by the quality assurance team, and they work independently from the developers. Then we have the deployment and maintenance stage, and the product is deployed here and goes into a maintenance mode. If the patch is created, then here quality assurance team is brought in again, and the team ensures that no new issues are introduced into the product. If a new iteration is needed, this cycle is repeated. Of course, we have some SDLCs that does iteration, and we'll look at a few of them. How do we then integrate security into the SDLC? Now, SDLC process involves many people. We've already seen the quality assurance team. We've seen developers. Now, changing the entire process at once will not be efficient, and it will be very difficult to do. The best is to introduce the consideration of security gradually, and this effort should be sponsored by both the security team and the development team. So the first step to look at is verification and testing. So here the quality assurance team can be trained to perform basic vulnerability assessment, and the security team is often heavily involved in this, and it can include the use of automated security testing tools, which we will look at some of them. You can also scan applications in a testing and or staging environment that mirrors production. Now, even in verifying and testing, how do we prioritize web application security testing? There are a number of them, or a number of factors that plays a role in prioritizing the applications. We are looking at sensitive data, we are looking at number of users, we are looking at internal and external facing applications. And if multiple application groups are involved, then we need to consider beginning to introduce testing to an initial pilot group. And here we can use the Microsoft Dread analysis to prioritize vulnerabilities. Now, the Dread simply is a risk rating tool. D, which stands for damage potential. R, which stands for reproducibility. E, that stands for exploitability. A stands for affected users. Then D, the last D, is discoverability. And all these have their various scores and how to test each, or how to assess each of these scores. Then still under verification and testing, we want to look at reporting and remediation. And here we are saying we communicate security issues findings to development. And there's also a need to ensure that the discovered issues are documented and they are tracked. And once they are fixed, reassess the application in the same stage or test environment. Then the second stage is implementation. Here we begin to make basic security testing parts of unit testing, and developers should go through web application security awareness training. At this point, the security team might play more of the monitoring role and not be as heavily involved in the verification part. Then the last stage we want to look at is the analysis and design. So we are saying in integrating security, there are three phases: verification, implementation, and analysis and design. So here, the final stage is introducing vulnerability testing in the software development lifecycle. Now, threat modeling can be employed to take security into account. And here, Microsoft's Thread and Dread formulations could be an effective tool. We'll look at those into details soon. Now, threat modeling. Risk analysis process are being developed by Microsoft, or have been developed by Microsoft. And OWASP, as we saw in our earlier sessions, recommended this for its ability to deal with application security. It identifies threats and associates appropriate countermeasures to them. Now, this is a typical threat model process. So we have the identity, asset, we compose the application, document the threats, then identify mitigation strategies. There are 7 of them. At identify the threats, we can use the STREAD strategy, and rating the threat, we can use the DREAD strategy. So in identifying the threats, STREAD simply means spoofing identity, tampering with data for the T, then repudiation. Here, associated users who deny performing an action, yet there is no way to prove that they didn't do those actions, is being analyzed. We have the I for information disclosure, D for the denial of service, E for the elevation of privilege. Then, as we looked at earlier on, ranking the threat, we will use the DREAD, and we've already spoken about the definitions: reproducibility, exploitability, affected users, discoverability. Now, some security teams also have some challenges. How many of them have we assessed? How many of the applications have we assessed? Which ones present high risk? What are the most common mistakes developers make? And these are security teams' challenges every day. Now, we can evaluate these application risks. And applications are evaluated to determine their risk. Based on the risk, different security workflows may apply. So we are looking at from as low to critical. So we have low, medium, high, and critical ways of assessing application or evaluating application risk. Then we have application consideration. How does data enter an application? Is it through data entry? Is it by selection? What is even the nature of the client? Is he using a web or the mobile? How many people are using the system? Number and types of users. The architecture comes into play. Is this system-to-system connection? Even a kind of technology use comes into play. Now, threats and risks. We have internal versus external users. And of course, internal users are often granted a higher level of access, whilst external users may be customers, business partners, and the likes. We have authentication or authenticate versus open access. Authenticated access is typically required for applications that intuitively need protection. They need some level of protection. Often, capabilities are completely outside authentication. Features like search are good examples. And we've also looked at, for threats and risk, we've looked at privilege escalation, talking about the vertical and the horizontal privilege. We've also looked at data exposure. One factor in risk analysis is the kind of data that is being exposed, and that is exposed to potential breach. Then we have the security objectives. We've spoken about SAST and DAST at length, and here the AppScan standard and AppScan enterprise tools can be used to assess this risk. Then we have the scan and testing of results. Here is risk analysis. We evaluate the likelihood of the exploit happening, how many times or how many things to consider, or there are many things to consider here. How many users are affected? How easy is it to exploit the weakness? What is the potential cost of an exploit? And here we're talking about monetary terms. Is the authentication needed to exploit? How easy is it to reproduce the weakness? Then we look at track vulnerabilities. We need to track the risk and ensure mitigation. Now, how long are risks allowed to be exposed? Is it high risk findings? Is it medium risk? Is it low risk findings? The process must be repeatable and not a one-off activity. Now, we look at security testing within the software life cycle. Now, we have coding, building, quality assurance, security, and production. Now, you will see that most issues are found by security auditors prior to going live, as in going to production. So we see the arrow being high for security. Now, this is the optimal way. It's expected that percentage of issues found by the stage of software development life cycle stems from a higher point, and as we approach production, we see that the percentage of issues comes to the barest minimum. And this is the desired profile that we need to see in implementing security in software life cycle. Now, there are various life cycle approaches, as I had mentioned earlier on. We have the iterative waterfall approach, and here we have the static analysis where AppScan can be used. Also, we have the dynamic analysis where AppScan Standard or AppScan Enterprise can be used as a tool. Then we have the penetration test that has to do more with security, where AppScan Standard can also be used. Now, identifying security flaws earlier in the SDL is very key and important. We also have the Agile Approach. You can read on this later. We have, now what happens in this process is that there are some iterations that needs to take place, and that's typical of the Agile Approach. Now, for the Agile Approach, there are some security challenges. We are talking about quality assurance, may incorporate automatic processes. We are looking at how to make automated quality assurance tests feed into security test cycle. There is an increasing need to automate security testing. Now, there's also a need to embed security into Agile. Now, we can look like during the iteration phase, especially for the daily review, we can see some security defects in there. Here also, AppScan Source and AppScan Enterprise can be used in filtering high confidence in these applications. Now here talks about the pen testing team and how that can benefit the development life cycle. So we looked at development, quality assurance, and the security team. These three teams working together to have integrating security into software-defined life cycle. Now, using dynamic and static scan results can improve the security team's effectiveness. So here in summary, we've been looking at how to implement web application security testing in the Sdlc software development lifecycle, and we've seen how to use threat modeling techniques such as threats and threats to assess and prioritize web application security vulnerabilities. This will bring us to the end of session 13. Thank you.